Question number 80. The switch S in the figure is kept closed for a long time and is then opened at t equal to 1. Find the current in the middle 10 ohm resistor at time t equal to 1 millisecond. So here, during the charging, switch S remains closed. In that case, these two resistances are in parallel. So equivalent resistance R equivalent will be 10 into 10 divided by 10 plus 10, that is 5 ohm. Now, current will be equal to I equal to 12 divided by 5, that is 2.4 ampere. Here, if we find PD across 10 ohm resistor, PD across 10 ohm resistor equal to IR, so it is V1. So that will be equal to 2.4 times 10, that is 24 volt. Now we find charge stored. So Q0 equal to C and voltage. Here, voltage for this purpose will be the voltage across this 10 ohm resistor. So that will be equal to 25 into 10 to the power minus 6 times 20, sorry, into 24. That is 600 into 10 to the power minus 6 coulomb. Now, during discharge, because switch is opened at t equal to 0, so case of discharging, Q equal to Q0 e to the power minus t upon RC. Q0 is 600 into 10 to the power minus 6 into e to the power minus t. Time is 1 into 10 to the power minus 3 divided by R. The resistance is here. It is, we have evaluated as, but we need for this circuit only because switch S is open. So resistance is 10 ohm and the C is 25 into 10 to the power minus 6. So this will become 600 into 10 to the power minus 6 into e to the power minus 4. And we know that E equal to 2.72. So if we evaluate it, it will become 10.99 into 10 to the power minus 6 coulomb. Now we have to find out the current to this 10 ohm resistor. So we have Q, so Q equal to IT. So I equal to Q 10.99 into 10 to the power minus 6 divided by time. Time is 1 millisecond. So 1 into 10 to the power minus 3. So this will become 10.99 into 10 to the power minus 3 ampere, which is roughly equal to 11 milliampere. So this is our answer. Now consider question number 81. Here, a capacitance whose value is 100 microfarad is connected across a battery of 6 volt through a resistance of 20 kilo ohm for 4 seconds. The battery is then replaced by a thick wire. What will be the charge on the capacitor 4 seconds after the battery is disconnected? So first of all, it is being charged for 4 seconds. So Q equal to Q0 1 minus e to the power minus t upon RC. So we put the values. Q0 means CV0 So here C is 100 into 10 to the power minus 6 into voltage means C. Here V0 is voltage applied by the battery, that is 6 volt times 1 minus e to the power minus 4 divided by RC. So resistance is 20 into 10 to the power 3 into capacitance is 100 into 10 to the power minus 6. So this will become 600 into 10 to the power minus 6 into 1 minus e to the power, and we evaluate this. So this will become this 2, so minus 2. And we know that E equal to 2.72. If we evaluate it, so this will become 5.184 into 10 to the power minus 6 coulomb. Now, case of discharging. So Q equal to Q0 e to the power minus t upon RC. So we take this as Q0 this time. So Q equal to 5.184 into 10 to the power minus 6 into e to the power minus t upon RC. And t upon RC will be same as above, so e power minus 2, or 5.184 into 10 to the power minus 6 divided by e square. And we put the value of e this. So we will get 70 into 10 to the power minus 6 coulomb. So that's our answer. Now let's go to next question, question 82. Consider the situation shown in the figure. The switch S is closed at t equal to 0 when the capacitors are uncharged. Here there is switch. So it remains now. So the switch is closed at t equal to 0 when the capacitors are uncharged. Find the charge on the capacitor C1 as a function of time. Now, here when switch S is closed, the two capacitors are in series. So C equivalent will be equal to C1 into C2 divided by C1 plus C2. Now, when switch S is closed, it means it is charging. So case of charging, Q equal to Q0 1 minus e to the power minus t upon RC. So here Q equal to CV we apply. So C equivalent is C1 C2 divided by C1 plus C2 times V is applied voltage or EMF E. So we put this value here. So Q equal to C1 C2 divided by C1 plus C2 into E times 1 minus e to the power minus t upon RC. And this is our answer. Thank you for watching.